Alright, so this is how you could calculate the pressure. Now I pulled up an online calculator so that I can show you how I would do it. So flip to the back of your page and you're going to look at number 1. What was the calculated pressure on your tower? You have to pick. Do you want 33 pounds on your tower for 3 sides? Or do you want 25 pounds on your tower if you had 4 sides? I would highly recommend pulling it off at 3 if you can. Now, 3-sided tower held 33 pounds, and once again, I got that number from 100 pounds divided by 3 sides. Gives me that long number, and I just shortened it to 33.33. Okay. And once again, the 25 came from 100 divided by 4 sides. This you should know, it's just like money. All right. So I need to figure out, and I showed in the last video, on how you could find the width of your tower. Hopefully you go back to Edit Sketch and check that dimension. So assuming I know what that is, I got 33.33 pounds. I'm going to divide it by the area of the top face of the tower. Everyone should have 0.125. That's the thickness. Times, so this in parentheses is just the area of our tower. So 0.125 times the width of my tower, which is 5. And I'll close the parentheses for this calculator. So my pressure would be 53.32. Now, if this looks a little bit different, maybe you did 33 divided by 0.125 times, a lot of us, let's go back, times 5. So a lot of us have this. And if you started off with 33, notice how your answer is going to change. I started off with 53 point something. If you just round off to 33, you get 52 point something. It's really better to be as accurate as you can. So go back, really use those extra decimals. Use 33.33. And then keep doing the calculation that way. All right, let me clear this all. So I would need, in my case, I'm just going to go back, 33.33 divided by 0.125 times 5, close parentheses, equals. This is the number that I would put in Inventor. So I would go back to Inventor and put this in as the pressure. So this would be my load. Instead of using a force, I would go to pressure, and I would use that 53 point. Let me go back and double check what I had. 53.32. 53.32. I have to tell it where to go, so that's where this goes. And I'm going to go OK. Now the pressure will look different because it has more arrows. And really, it's supposed to stretch all the way across your tower, so this is more symbolic. The first picture was literal for just the force, but this is now symbolic to let you know that it is going to stretch all the way across your tower. Okay, let's see if this makes a difference. That's done, that's done. We're going to simulate and run. And we're going to wait until it's finished. And we're going to jump to safety factor, double click. Now I have a 1.36 safety factor. Was that any different from my very first one? Let's compare. So I have a 1.36 safety factor as a pressure. Thankfully nothing failed, so everything stayed yellow. Let's see. I'm going to go back because I don't remember. Let me edit this. I'm going to delete. I'm going to put a force, and let me just put this 33.33 pounds. I'll flip this over, put it on the surface, Okay, I want you to see something. See how it says edges? And I have got an arrow that points sideways. That means I clicked on the wrong thing. So I gotta cancel. And I gotta start over. So force. I do want that 33.33. And I want to make sure I got the right thing. So I want to make sure that it's a face. And this shows up as faces. Okay. Let's look at this again. Let's simulate this again. And run. And we're waiting. And we're double clicking on safety factor. Interesting. I got the same minimum safety factor whether I did a load in the middle or a pressure in the middle. Now for my tower, it probably didn't make too much of a difference because I have this middle stick that keeps it strong. But for you, depending on how you designed it, you could get a very different safety factor if you do a force versus a pressure. So keep that in mind. That's why I have that on the page, so that you can compare what's more realistic, a force or a pressure. In our case, a pressure is realistic because we're not pushing with a finger. We're applying a force, and those plates are pretty big. So the plate goes across the whole top of the tower.